Hello class 10. In the last lecture, we have completed all the theory parts of chapter 1. In this lecture, we will discuss about few numericals because we are not giving any information that how many questions you are doing or what problem you are facing in a numerical problem. I'll do some numerical problem. Now let's see. I'm starting with one question. There is written calculate moment of force about A, B and C taking the radius of this wheel or circle is 2 centimeter. See the diagram carefully. 3 points A, B and C. A and C are at the circle of the circumference while B at the center. The question says moment of force about A. About A means take A as the axis of rotation. About B means B is the axis of rotation. C means C is the axis of rotation. So here taking about A. If you are talking about A, to calculate moment of force, we have the equation. Moment of force is equal to force into perpendicular distance. So what is the value of force here? See the diagram, 10 9. And what is the perpendicular distance? The force is applied at A and we have to calculate the perpendicular distance from A. The distance is 0. So here see the value of force is 10 9 and the perpendicular distance is 0. It gives value 0. So moment of force about point A will be 0. Now second question is moment of force about point B. When we will talk about the moment of force about B means the body will rotate through this path and B will be the axis of rotation. At that time the force will be same but the perpendicular distance will be 2 centimeter as the question is given. 2 centimeter the radius of the circle. So about B, the moment of force equal to force into perpendicular distance, force 10, perpendicular distance 2, so it becomes 29 centimeter. About A it is 0, about B it is 29 centimeter. Now the next question about C. From this force means you can say point of application or you can say line of action. The distance of C is 2 plus 2, 4 centimeter. So again the moment of force about C, you can see here 10 cross 4 and the moment of force becomes 49 centimeter. Means about A 0, about B 20, about C 40. See here again. About A means the body will not rotate. About B means the body will go through the surface circumference, and about C means the body will go from here. It will rotate to this direction. It will come to here. So this was the numerical problem. Another question of practice problem 7, question number 1. The question is uniform meter scale of weight 50 gram force is balanced at 40 centimeter mark when the weight of 100 gram force is suspended at 5 centimeter mark. Where must a weight of 80 gram force be suspended to balance the meter scale? So I have drawn here a meter scale 0 centimeter and 100 centimeter. I have marked here. It is written that uniform meter scale of weight 50 gram force. I have informed you that weight is acting always at the midpoint. It is having the length of 100 centimeter. In the question it is written uniform meter scale. So this is 100 centimeter makes 1 meter. 50 gram force is the weight of the scale. So at middle it will be 50 gram force will be acting. So see at 50 centimeter mark the 50 gram force weight of the scale is acting. See here the meter scale weight 50 gram force is balanced at 40 centimeter. This is balanced means fulcrum is at 40 centimeter. Let's put here at 40 centimeter. See here the fulcrum at 40 centimeter. Now when the weight of 100 gram force is suspended at 5 centimeter. So at 5 centimeter mark I am going to suspend 100 gram force somewhere here. Like this 5 centimeter position and 100 gram force is suspended here. Now mention the distances from the fulcrum. So from here 40 to the 5 or you can say 5 to 40 the distance will be 35 centimeter. And why we are taking this displacement? Because we need the moment of force for the moment of force and the perpendicular distance. For this one this is 10 centimeter. Now calculate the moment of force in this direction. 100 into 35, 3500 in the anti-clockwise direction. 50 into 10, 500 in the clockwise direction. Let's read the further question what is saying. After this point, where must a weight of 80 GF be suspended to balance it? 80 GF. So we have the two options, either in on this side or on this side. So I have said that in anti-clockwise direction, the moment of force becomes 3500 and the clockwise direction makes only 500. So it is clear that 80 gram force will be suspended somewhere in this direction. I don't know. Let the point is somewhere here as this, and the perpendicular distance let x. This we have to find at what distance the 80 gram force must be suspended. Same thing, this is going to the clockwise direction, this is going to the anti-clockwise, and this one is also going to the anti-clockwise direction. So according to the principle of movement, let's put that. According to principle of movement, the clockwise movement is equal to anti-clockwise movement. This one and this one are in the clockwise direction and this one is in only anti-clockwise direction. So let's put the value here. See here, the clockwise direction, this one 50 the force and 10 is the displacement, so becomes 15 to 10. This one 80 gram force the force and the displacement is unknown, so I am writing 18 to x. And for this one, anti-clockwise movement is 100 gram force into 35. On further solving, it gives 500 plus 80x is equal to 3500, or 80x is equal to 3000 only, or x is equal to 3000 upon 80 and x is equal to 37.5 centimeter. So 37.5 centimeter is the distance from here to here. If you are writing the answer 35 centimeter, 37.5 centimeter, so you must write from the fulcrum 37.5 centimeter from the fulcrum to the right side. But if you want to write the perfect answer, so write the distance from this point to that point. So from here to here it is 40 centimeter and from here to here it is 37.5 centimeter. On adding both the distances, what you will see, position of the 80 gram force weight is equal to 40 plus 37.5 gives 77.5 centimeter mark. This is complete solution for this question. So we have done with the theory part, we have completed some numerical. If it's still you are facing any problem, inform me with the practice problem and the question number 2. Now we are switching to our next chapter, work, power and energy. Starting with the first topic, work. For work to be done, there must be first force, displacement, and third, displacement in the direction of force. Suppose this body is acted upon by the force F, and due to the force F, it is displacing the displacement by S. So the work done is equal to the product of force and the displacement, means W is equal to F into S. In this equation, W is equal to F into S, the force and the displacement both are vector quantity, while the work is a scalar quantity. So their product is called dot product. This will be explained in the class 11. We have not to worry about that. The thing is, W is equal to F into S. So points were, there must be force, there must be displacement, and the displacement must be in the direction of force. What if the displacement is not in the direction of force? In this case, the force and the displacement both are not in the same direction. They have the angle between them, suppose theta. So at this time, the component of force will work. The component of force will be F cos theta. So the work done becomes W is equal to F cos theta into S, or you can say Fs cos theta. The component part is not in your syllabus. You have to remember what? W is equal to Fs cos theta if there is an angle between the force and the displacement direction. If the force and displacement both are not in the same direction, they are having some angle between them, at that time you will use the equation W is equal to Fs cos theta. So the definition of work is, to be work done, there must be force and displacement. That displacement should be in the direction of force. Suppose this wall, I am pushing this wall, I am applying force. So is there any work done? Using this case, there is force. See, there is force. but there is no displacement. According to the definition, there must be force and displacement, and the displacement is the direction of force. So we are having the force, but the wall is not displacing. So due to this, it is incorrect. So there is no work done. Take another case. This suitcase. I'm taking this suitcase in this direction. Is there work? In this case, the suitcase is at my head. The weight of the suitcase is acting downward. But when I am taking this in this direction, there is a displacement in this direction. So there is an angle between the force and the displacement is 90. And we have the equation W is equal to Fs cos theta. So it becomes Fs cos 90. So the work done becomes 0 because angle is 90, cos 90 gives 0. So in some cases, physics says there is no work. Even the person will be get tired, but there is no work. Another example, suppose I am carrying a bag on my back. Still, the weight is acting downward and the displacement will be in any direction horizontal to the surface. At that time, the angle will be same. Some other example, the revolution of planet around the sun, like this. In this case, the velocity and the centripetal force, you know the centripetal force toward the center and the direction of velocity is tangential. The angle between them is 90 again. So the work done is 0. So there is many cases in which the work done is 0. But if the work done is 0, in some case the work done is positive too. When the force and the displacement are in the same direction. If they are in the same direction, so angle between them will be 0. So cos 0 gives value 1. So W is equal to plus F into S. But when the work done will be negative, on raising the box up, the weight is acting downward. The displacement is going in upward direction. So angle between them is 180. So we have the equation W is equal to Fs cos theta means cos 180. In this case, cos 180 gives value -1. So work done is negative. Whenever the object is moving in a one direction and the force is acting in the opposite direction, at that time the work done will be negative. Like when player hits a ball, cricketer hits a ball, the ball is coming in this direction and the force applied on that direction, so work done negative. Suppose you throw a ball, after some time it comes to rest because the friction force is acting opposite to the direction of motion. So force in the forward direction, friction is in opposite direction. At this case, in these cases, the work done is negative. So after the definition and some examples, let's move about the unit. The work done is the product of force and displacement. So the unit becomes the product of force and the unit of displacement. The unit of force in SI is Newton and the displacement is in meter. So its unit becomes Newton meter in SI system. But do we remember that Newton meter was the unit also in the moment of force topic? So we must change to remember it. So I'm changing this Newton meter to joule. So whenever you are writing the unit of work, write joule. And whenever you are writing the unit of moment of force in a SI system, write Newton meter. This is to just differentiate between the moment of force and the work. And one more thing, the moment of force is a vector quantity while work done is a scalar quantity. Same way, it also having the unit in CGS system. So in CGS system, the force has the unit dyne and the displacement has the unit centimeter. So it becomes dyne centimeter. Again, the same problem is coming. So we will say the erg, ERG, the dyne centimeter is equal to erg. So this is done about the unit. So the relation between the SI and the CGS system of the unit. If the basic units, basic dimension are same in the moment of force and the work, so the relation will also be same. But you have to remember that you have to change the name. There, Newton meter, dyne centimeter. But here, about the work, you will write Newton meter. No, you will write joule and erg. So see the relation between them. The 1 joule is equal to 10 to the power 7 erg. Okay. So I am ending this session today. I am completing the topic up to the units only. The next topic will be power and something more. So in the next lecture, till then, thank you.